Hi everyone, welcome to Kubernetes workshop. We'll start in a few minutes. Okay, so I've added a Google Meet link in the video description, and you can join the Google Meet if you want to discuss any of the troubleshooting steps when we are doing the lab, and you have any specific question, you can join in and we can discuss that. If you join, make sure you mute your YouTube video, otherwise there will be echo. Okay, so if you're not already familiar, this is our website, shrln.com, SHRLRN. You can find different information over here, like a link to Docker Labs. You can book a quick 15 minutes appointment to talk with us. And there are Kubernetes Labs. You can also see upcoming workshop information over here. If you click on it, it'll take you to Eventbrite and you can sign up for those. The next one for Docker is already here. The Kubernetes is today's. We're going to update it to the next workshop. Video of the Docker workshop is already available over here, and same thing with the Kubernetes workshop. We will be updating them, and in future you can see them going into the event side of it. So if you go learn and you see conference, this is where you will be able to see the past information. On our website, we also have information about the different blogs you should follow and read along to understand what is the latest companies are doing. We also have information about different courses, and all the labs are under the practice section. So you can find the Docker labs and Kubernetes labs. We'll be adding more Kubernetes, Docker, and Linux and Azure labs as well. In order to do any of our lab, especially Docker and Kubernetes, the resources are provided by Docker Hub, and you would have to register here with the unique ID, and then you have to pick an email address and a password here. Once you click on Kubernetes Labs, it'll take you to this page, and you can click on one of the lab that will bring the steps in there. And the first step is or step 0 is to create a Docker Hub account and then open Play with Kubernetes. Click on Start. So we will go through it once we complete the basic of Kubernetes. So Kubernetes is also known as K8s for the 8 letters between K and S. It's an open source container orchestration system for automating computer application deployment, scaling, and management. Essentially, what it does is you tell it what do you want in the containers, and it'll create those containers, remove those containers, and maintain the number of containers you have specified. There's auto scaling, there's load balancing, and a lot of other features you can configure with it. Essentially, when you use containers and probably using a container runtime tool like Docker, you would need some thing to orchestrate. Otherwise, you have to manually create individual containers and make sure they're up. And Kubernetes will do that job for you. So it started as a Borg internal in Google, and then um, turned into Omega, and then Kubernetes is what Google has open sourced. So it's also called Linux kernel of distributed system, abstract away the underlying hardware of nodes and provide a uniform interface for workload to be both deployed and consumed, the shared pool of resources. So you give the number of servers, you configure them, add them to the Kubernetes cluster, which will be going in detail. And then it, as an application developer, or when you are trying to consume those resources, you don't have to worry about which server it is going on to, whether that server is up or not. Kubernetes will take care of those for you. So it's a desired state system. You just tell it that I need 10 of these containers, and Kubernetes will take care of it. If one of them goes down, it'll bring another pod, and then you'll have a consistent desired state as long as resources are available. If a significant number of servers are not working, then of course that's another problem we have to work on. It decouples the infrastructure and scaling. All the services within the Kubernetes are natively load balanced. So whenever you expose a service, it acts as a load balancer. So the traffic from outside hit a service, and service will send it to one of the pod, which is in the group of that service. You can scale up and down dynamically, use both to enable self-healing and seamless upgrade or rollback of application. Kubernetes, as we discussed, will always try and steer the cluster to the desired state. So if you say, I want 5 healthy instances of Redis to be always running, Kubernetes will say, okay, fine, I'll bring them up. And if one of the instances has an issue, Kubernetes will attempt to spin up a new one. So it can auto scale workloads for you. You can do blue-green deployment. You can do canary as well. You can do fire off jobs and schedule cron jobs, manage stateless and stateful applications, provide native methods of service discovery. So you don't have to configure anything for the services. You just create a service and the labels will automatically add the pods behind the service. You can easily integrate and support third-party apps. It uses the same API across the bare metal and every cloud provider. So if you use the Kubernetes and make the API calls to the Kubernetes, you don't have to worry about whether you're running it in your private cloud in your own data center or you have it in any of the cloud provider. So who manages Kubernetes? Kubernetes is managed by Cloud Native Computing Foundation. It's a child entity of Linux Foundation and operates as a vendor neutral governance group. Project has over 71,000 stars on GitHub, 2,000 plus contributors, and their Slack group has more than 100,000 users on it. When you deploy Kubernetes, what you get essentially is a cluster. So there will be a master node, and there will be other servers will just classify it as node. You will have at least one master and worker node, unless you're working in a development or a learning stage or a test stage, where you can have a master node work as a worker node as well. In production, it is always recommended to not put any workload or any of your use case on the master node. So in terms of architecture, it has a control plane wherein it has the controller manager. So all the objects inside the Kubernetes are managed by the controller, and then API is actually the interface in between. So anybody has to, any component within the Kubernetes, if it has to communicate with other one, it has to go through the API. So it's always an API call. etcd is the brain behind the Kubernetes cluster. So that's where all the information of what all what you desire, what is the current state, what is the resources available, everything is stored in the etcd. And scheduler is the one who decide where the pod will go. So the smallest unit, which we're going to cover in the next slide in Kubernetes, is a pod. It can have one or more container inside it. And scheduler will decide which node the pod should go to. Every node will have a kubelet, which will communicate with the container runtime, and a Kubernetes proxy, which will communicate on the network scale. Again, this is a basic workshop, so we'll just overview and take it further in depth in the future workshops. So pod, it's the smallest unit of work in Kubernetes. It could have one or more container inside it. It will have its own network space and storage space. So it'll have its own storage and could be stateful or stateless. And it'll have its own network and IP address and entire TCP/IP and UDP stack. It could have a second container, but as a use case or as a regular practice, whenever you have a second container, it's either a sidecar or ambassador. We'll cover those in the future ones. Right now, our effort is to get your hands dirty with the labs as soon as possible. So we're just giving you an overview. And they're ephemeral. So most of the pods will be stateless. If a pod goes down, Kubernetes will not gonna attempt to bring that same pod back, rather just spin up a new one. So how do we overcome that problem is with the services. So service act as a load balancer. Whenever traffic comes from outside, it'll go to a service. Service will take it to one of the pod, and depending on the labels we have put on the pod. So let's say there are pod with the label app nginx and environment prod, and in our service we said whatever has the label of app nginx and environment prod, just send the traffic to those. So whenever traffic from outside hit the service, it will be sent to one of the pod behind it with the same label. And they are not ephemeral, so services do not, if anything happens to the node, services will still stay up as they run on the every node or on the cluster level. So that completes the basic part of it. Any questions you guys have? Okay, in that case, let's move on to the Lab 101. Again, if you have not created already, create a Docker Hub account. It's fairly simple. You have to pick a unique ID, put an email address, password, and you can choose if you want to get an update and announcement from Docker. Um, Make sure you're not a robot or scripting it, and then do a sign up. So let's go to Kubernetes Labs and let's go to the first lab. And here, step 0 is Docker Hub account. If you have not created already, create one. Again, to get to this place, you go to sharelearn.com and then go to Kubernetes Labs. So a pod is actually where your binary or your program will gonna run. And a service is a load balancer. So it is a virtual entity which will gonna group all your pods, similar pods. So let's say you have a web server. Let's say I have a ShareLearn hosted on a pod, and I have 10 pods serving ShareLearn. I'll put them behind a service. So when you type in share learn, you'll be going to a service, and service will decide which one of the 10 pod the traffic should go to. And then the pod will process the traffic, send you the appropriate information, and it'll send it to the through the service back to the client. Coming back to our flow, if you want to go to Kubernetes Labs, just click on this, go to the first lab, and here click on Play with Kubernetes. This will take you to the labs.play with Kubernetes. Click on Login with Docker, sign in, and click on Start. So here, this will start a 4-hour session for you. It's completely free. You can do it anytime you want to. Always, you'll have a 4-hour limit. Understand that sometimes, uh, as there are limited resources and this is free of cost, you might hit a situation where they are out of resources. Just wait for a few minutes or refresh, and you will get those resources back. So yes, when you're coming from outside the Kubernetes cluster or even inside, you will be hitting the service to access your web page or your application, and service will route you to one of the appropriate pod. Let's come back here. So we open the Play with Kubernetes and log in with Docker Hub account. If you guys are trying to follow, you can follow these steps with me here. It'll start a 4-hour session as it did for us, and then we have to click on Add New Instance. So if we come back here, it'll be Add New Instance. Services are ephemeral, so services do not, uh, by ephemeral, it means like pods are ephemeral. So if a pod has an issue, Kubernetes will delete it and create a new one. But services, if they have an issue, they're not getting deleted, or they're going to stay till the time the cluster is there. So in this case, we're going to create 4 instances. Let's come back to our lab. In the lab, we're creating the instance one by one, but in the workshop, to save the time, I just created all 4 instances altogether. So let's copy this command, and I'll explain it what it is doing. So kubeadm is one way to create the Kubernetes cluster, and we're using that in this instance. We're saying we want to use kubeadm, and we want to initialize a cluster. Then we're talking about API server, and we're saying API server advertise address. Here we're giving a hostname-i, which is the IP address of this server. And then we're saying for the pod networks, so the smallest unit in the Kubernetes, which is pod, we're going to use the subnet of 10.50.0/16. So if the node goes down, services will not be impacted. Only the pods will be impacted. If you have a service which has 10 pods behind it, and 5 of them got impacted, you still have 5. So traffic will be routed to the 5, and Kubernetes cluster will stabilize it by creating those 5 pods which have been deleted somewhere else. So how do we know how many requests a service can handle if requests are hitting the container inside the pods? It's a capacity. So essentially, all services doing is taking your traffic and sending it to a pod. So you need to have enough pods behind a service to be able to handle your traffic, and you have to do capacity planning. You're putting exact resources in the pod and how much it can handle, and you'll do a test run, and just like you do other capacity planning, you're going to plan how many pods you need to put behind it and how big the pods should be. So EKS, GCP, and Azure has 2 ways of doing Kubernetes. One is you take their their own service. So they'll give you the cluster pre-built. You don't have to do anything. You just have to use it for your application. So you have to create the service, the pod. We're going to be seeing the deployment and replica set as well. Those are hierarchical models. So we don't, in the production environment, we don't create a pod. We create the deployment, which creates a replica set, and replica set creates the pods. So in the public cloud environment, if you're using EKS, you don't have to worry about whatever we're discussing in Lab 101. They'll provide you a cluster. If you're using GKE or AKS, you don't have to worry about it. But there's another way. If you want to build your own cluster, then you will have to you can get the VMs from Azure, AWS, Azure, or GCP, and create a cluster on the top of it. Then you would have to use one of the tool. Doesn't have to be KubeADM, but KubeADM is one of the tool to administer the Kubernetes cluster. So another question is, what if all the pods got deleted? Then the service will not be able to provide you any resources. So if all the pod, let's say I'm hosting my share learn on Kubernetes pods, and I have 10 pods to serve it, and all 10 are dead. Then you will not be able to access the website. The service will be down. So here we're gonna press enter on Kubernetes with the API server and the pod subnet. What KubeADM we're gonna do is, as we saw, the control plane require its own set of pods. So it'll gonna pull the uh, container images, and if you need more refresher for those, I will gonna link the detail of the workshop we had yesterday on Docker, and you can understand how the container images work. But for the control plane as well, everything we talk about, API, scheduler, it'll be working as a container in the Kubernetes clusters. Sorry, as a pod in the Kubernetes cluster. So here, while we're waiting, this system is trying to fetch the images for that control plane. You can do it proactively by doing kubeadm config image pull. Yes, kubeadm primarily for the private cluster, and I've seen use cases where companies will get the VMs from the public cloud provider and build their own cluster. Anytime you take a service from the cloud provider, which is pre-built, you're getting it's kind of get restricted, and you have to accept what they're offering you rather than making your more choices. So if you build your own cluster, you can choose what you want. But if you're taking GKE, EKS, or AK, um, GKE, EKS, or AKS, you will have to go with what they're offering you. So if you want complete flexibility, you have to manage your own cluster. But if you're taking their cluster, then you don't need to worry about the kubeadm or anything in this lab. In the 101, you still have to create your own pods and do things like that. So C groups is essentially the way to isolate resources. It's more related to container runtime. Docker is one of them. Kubernetes always use a container runtime underlying. Recently, Kubernetes has announced that from 1.20, 1.20 or 1.21 onwards, they will be depreciating the use of Docker and using other container like Containerd or something. So um, to answer your question, yes, C groups will be used, but not directly. You will not be configuring anything related to C groups when you're using Kubernetes. That'll be the underlying effects of how Kubernetes manage containers and resources for containers. So we have, if we don't provide this, every pod has its own IP address, and they have to pick the IP address from a pool. If we don't provide it, it'll take a default pool, which might already exist in our environment. So it's always recommended that you provide the pool. So the your entire cluster is deterministic and you know what to expect. Okay, so here it has completed the process for us and given an output where it says kubadium join. So on the worker or the normal nodes, all we have to do is go to them and run that command. So here we'll just do join. We have to take it with the all the options. So one of them is token. That's kind of a secret. Uh, this node has to offer to the master and say that I want to use this and join the cluster. And the discovery is the other side of it. So to authenticate the master. So it communicates to the master and join the cluster. Just to understand, Kubadium and Kubadium, kubectl, and kubelet also needs to be installed in this lab. These are pre-installed. We're working on a little advanced lab where we will take it from the ground up, just like you get the VMs and you're working on them, or you get the bare metal and working on them. Yeah, as this is a basic lab, we want you to get your hands dirty as soon as possible. So that's why we chose the pick the labs where the this is already set up for you. But it's pretty simple. If you're using Ubuntu, you have to use apt-get, install Kubadium, kubelet, and kubectl. And I'll show you where you can find the steps, more detailed steps. From our ShareLearn Labs perspective, we're still working on it. So we'll get you those labs out as well. So yeah, we did that on one of the node. Let's do that on another. We'll do that on all three nodes. And if you happen to, there is a possibility that instead of saying this node has joined the cluster, it'll give you an error. You have to restart the process and you will get there. Otherwise, you have to troubleshoot and see where the issues are. So if you're doing the labs on ShareLearn, this is a pretty basic lab. You have to do, for every other lab, you have to do this as you need a cluster to be able to create the pod or replica set or deployment. So all three nodes have joined. Let's do kubectl get nodes. This will show you all three nodes, fourth one including the master, but they're in not ready state. And the reason for that is there is a networking component or a plugin in the Kubernetes. That plugin, Kubernetes doesn't work on those. It left it for the public, for the vendors or another open source community to be able to build those. And they provide the guidelines for it. We will be covering Kubernetes networking in one of the upcoming lab, and we can go through those. But for now, what we're doing is all we're doing is we pick the Kube router as our plugin, as our network plugin, and we're going to use this command to install it on our cluster. So this is a YAML file. Usually it is recommended whenever you're using an external YAML file, you get it downloaded on your local computer and then verify it before you run it. But this is a lab environment and completely test, so we're just directly running it. Ideally, you'll do wget or curl to get this downloaded on your server, and then only you deploy it. So it created a config map, daemon set, service account, and cluster role, and things, whatever is required for the network plugin. We will be going into details in individual labs in future on those. We have some of them covered. Actually, we have none of them covered in the labs we have right now. We're taking very basic, and future we're going to cover it. So Kubadium join should be run on all the worker nodes. On the master, you'll be running the init command, which will initialize the cluster, and all the worker or normal nodes, as the Kubernetes call it, you have to run the kube join command. That's the only command you're going to run on them. So next time, we'll not be going to any of the worker nodes and do something on them. Uh, Kubernetes will take care of it. So all the pods which we create or have created, we're gonna pick the IP address from the IP subnet which we have provided or the CIDR we have provided. Yes. So that's what this lab is about, creating the cluster. So that completes the lab 101. I see the questions are coming up, and I'm trying to take care of them as they're coming up in the chat. Feel free, we can pause for a minute and see if you have any questions, what we have done so far. If you're trying to do labs with us and you have an issue, you can join the Google Meet in the description, and we can share your screen and work on it so that it helps everyone. So kubeadm config image pull is not the command you necessarily have to do, but it's just to alternate. What happens is when you initiate a cluster, it'll gonna pull the images for all the control plane components. So if I show you kubectl get pods minus in cube dash system, hope the demo gods are with us and it will give us the output. Okay, so you see that there's kube proxy, kube router, kube scheduler, API server, controller manager. All these pods have been created. They need the container image for them. So in order to get the container image, you have to pull it, and that's what that config image pull will gonna do. You don't have to do it, but you can do it proactively to speed up initializing your cluster. Okay, with that, that is lab 101. Let's go to lab 102. In this one, the step 4 does whatever we did in the lab 1. So every other lab other than 101, 101 is creating cluster, but all the other labs, you have to create the cluster first before you can do anything. So let's go to step 5 and do kubectl run web image nginx. And just to give a brief, in this lab, what we're doing is we're creating pod and services using the kubectl command. So we're just running the command and doing things and just getting our hands dirty. Yeah, we don't have to restart the cluster. The reason our core DNS is not coming is because the core kube router is in the init state, and that is required. So sometimes it's just the patience we need. Other times we have to troubleshoot. So if I go to get nodes, my nodes might not be ready by now. So let's see, because it's still getting the kube router. So 3 nodes are up and good, but my master is still not ready. So it's getting the kube router installed. So kube router here is the network plugin, which is kind of mandatory. Nothing would work without it. That's the reason our core DNS is in the 0 state and getting container created. You don't have to do config image pull, but yeah, if you do it once, you will pull all the images on your local server, and you don't have to do it again. No, it's not necessary. We have two core DNS. So core DNS is the DNS service within the Kubernetes, as every service or the load balancer service we talk about will have a domain name for it, which will be resolved inside the Kubernetes only. So the reason we see two Kubernetes is two core DNS is just for load balancing. Let's see if our control plane has got what it needs. Still not, okay. It should not take that long. Hmm. Ideally, we should see the image of Cube router as well. What I'm doing here is I see that the Cube router image is missing. In this case, we're using Docker as the container runtime. So I went into the Docker, look at what all images are available locally. And when I see the Cube router image is not available, I just went to another node and see that which kind of image we're using and trying to pull that now. Now, most of the time, you'll not face this issue, but if you do, we would have to troubleshoot in the underlying, in this case, it's a Docker, which is acting as a container runtime here. So we'd have to look into what exactly the issue is going on. It, Calico is just a network plugin. So in this case, we're using Kube Router. We could have got the Calico here. Yeah, so core DNS is for the resolution of the DNS within the Kubernetes cluster. So in the Kubernetes cluster, you'll have services and they'll have their domain name, which needs to be resolved. Okay, just give me a second, guys. It looks like we're out of image in this folder. So we're out of space in that folder. And I have seen that happening. Unfortunately, the only solution I've seen is rebuilding the cluster. So let's rebuild this cluster and I'll just go and delete it. And meanwhile, if you have any questions, we can discuss those. Yeah, and the number of installations is a question regarding to the capacity. So if you see too much DNS requests coming in, if you have so many services and you're seeing some issues in the DNS, you would have to scale up the number of core DNS pods. Okay, let's see if I can get rid of the entire session and just create another one. Okay. So it's not a good practice to close a session the way I did, because what happens is it stays in the background and it kind of put the burden on the free resources which we are trying to utilize here. These are provided by Docker, so we should respect what they're offering to the community. But for the sake of everybody's time on the call right now, I just did that quickly. Let's not change the lab structure, but feel free to book a quick time, and I'll be happy to discuss with you if you want to put Calico. It's no different. If we look at the Calico documentation, you just have to install Calico instead. So in order to join I'll show you as we are building the cluster again, I'll show you what exactly the command we need to do. And the one thing we need to remember about the join command is unique for every cluster. So it'll have the IP address, which is unique to your cluster. This is the IP address of the master node, not the CIDR or the internal Kubernetes IP address. Then there will be token, which is unique to your cluster. Same thing with the discovery token, zassert hash, which is unique to your cluster. So all we have to do is we have to run a command kubeadm join, get the IP address, a token, and discovery token. As you're getting just your hands dirty, the best way to take it is with this. So when you initialize your cluster, you get this command over here, which is kubeadm join IP address colon the service. So this is where 6443 is where the Kubernetes is accepting the communication from the other nodes on the master node. There's a token which is unique to this cluster, same as discovery hash, which is unique to this cluster. So let's add a new instance and we just do this. Let's speed up by getting the kube router here as well. You have to do kube router only on the master. Actually, you have to run any command you can think of. You have to do it only on the master. Only command you're going to do on the other nodes is the kubeadm join command. Let's quickly have just two nodes as we don't need the four example. Okay, my bad. Well, let's do kubeadm join over here on the working node. So kubectl is managing your cluster. kubeadm is administering. That means initializing, adding nodes. You use kubeadm to create the resources and manage the resources. You're going to use kubectl, and kubelet is the one which actually communicates to the container runtime and create the containers for you or delete the containers if required. Here we're checking how many nodes are there. Simple command is kubectl get nodes. So this time we got our master taken care of. If I do kubectl get pods in the namespace kube-system, we will see everything is running except our core DNS. They're still coming up. Let's go to the next step quickly and see if we face a challenge over there. So in this one, we're gonna use kubectl to create the cluster. Okay, for some reason our node one got deleted. Let's delete this one as well and try to create the cluster again. Well, I think with the limited, I'll try to cover these in the demo as well, but let's just go through the steps. So kubectl run, we're gonna create a pod for you. And in this case, I'm saying the pod which you're creating, name it as web. You have to provide the container image to be used for that pod. In this case, I'm saying use Nginx. Um, in order to delete it, you have to say kubectl delete pod web. Now, there's no point in creating the pods and not using them or not be able to access them. So we'll try to create the pod again, use the same image Nginx, and this time we're saying, hey, expose the port 80. So we're just giving a port number over there. This will expose the port on the pod, but pods are not what we access from outside. We access a service. In order to access a service, a quick way using kubectl is to say kubectl expose what you want to expose, whether a deployment, replica set, or a pod. In this case, it's a pod. name of the pod, so name of the object, the port number which pod is exposing, so what port number pod is offering the service, um, name of the service which you're creating. In this case, we're calling it nginx-service. What type of the service this is? There's different type of services. For now, we're just trying to expose it and test it. So take it node port. We're yet to build a lab on node port on the services, and it's a little deeper concept. We just want to get your hands dirty first. So let's go with it and take node port. And a target port is the one what service will be offering outside. So externally, people will be going to port 80 and they'll be able to reach the pod. So let's see if our cluster, okay. So QVDM join again. So this is the third time we're trying to build a cluster. Okay, it looks better. Let's see if we can create create a pod. So kubectl run web image nginx. It got created. Let's delete it. And I know it might sound like the steps which we're doing are not very useful, but they really help getting you absorb the commands, how they are being used. So I suggest using the labs with each command. I would recommend typing them, not even doing copy paste. I'm doing a copy paste to save the time, everybody's time over here. But my suggestion would be to get familiar with these commands and type them rather than copy paste. Okay, so it's taking time to delete it. While let me see what all questions we have. Yes, Kuberium join is a manual command. You can script it with Ansible or something, but it's just that one time you have to do when you're initializing your cluster. Once your cluster is built and initialized, it's formed, and then Kubernetes will take care of it. A node, we are deleting it because we had the challenge with the lab environment. That's why we were deleting the nodes and creating them again. So port of the pod is the container is exposing a port and saying that just like a virtual machine, if you install Nginx, it'll be offering services on port 80. So a pod is saying, I offer my services on port 80. So yeah, Shriram Mika, that's the one we can troubleshoot. If you want to join the Google Meet in the description, we can look at your screen. If you want to do it as personal, not with as a group, I after the workshop, I will end the YouTube live and I can work with you. So when to use node port, load balancer, cluster IP for better usage? That is a question for the services lab, which we are yet to work on. Let's quickly cover this, and we'll see if you have a few minutes. So I can answer that. Okay, so we got it deleted. Let's recreate it with the port 80. And next is to expose it. So we went through this command, kubectl expose. What object you're exposing is the pod. A name of the object is web. What port the object is offering the services on is 80. What is the name of the service, Nginx service? Type is node port, and target port is 80. So if I enter it, it's going to create a service for me. Let's do kubectl get pods. Sorry. get all, and it'll show you that it has created a service, which is a node port, and it is working here. Now, let's wait for our pod to be created and we can look into the questions. Yes, port 80 is the container port, and as this is the port which service will be using. You could have um, the the service to have a different port and container to have a different port. Again, a complex setup would not is not recommended, but it's in some cases you have to use it. So in most cases, you will see the container port and target port will be same, but there's a reason these are two different entities. Let's see if our pod has come up. Okay, it's running. So in the lab, if you want to access this service, what you have to do is go to a new tab and enter that URL, but we have to use this port, which is 30427. So we have to do kubectl get all, see what is a port which has been configured for the service. There, in the next steps, we're going to predetermine this, so you don't have to rely on a random port. But if you use the kubectl expose, it'll be a random port. So here, if I do colon and that port number, you'll see the page which is coming from the pod inside the Kubernetes cluster, which we're working on. Now you can of course change it. It could be different website or a different service altogether, but this is the use case which we're working on. Okay, next one is to create a service. So let's create a service rather than using the expose. This time we're saying kubectl create service. What is the type of service? Node port. And what is the name of the service? We're calling it Nginx Service 1 because we have already Nginx Service. Um, in this format, we're going to say TCP, what is our target port and what is the pod port. And we're explaining the node port as well. So this the port, which was a random port provided by the Kubernetes cluster 30427 in the previous case, this time we're saying we want it to be 30,001. So let's do that. And we got a new service, which is 30,001. It is going to the same pod as of now. So you might expect that let's do this and check, but this will be page cannot be displayed because the problem is by default, it expect a certain label to be available on the pod. So if I do kubectl detail service nginx one, sorry, it's kubectl describe service, you'll see that it is expecting a label of app is equal to service one on the pod to be added. That's why there's no endpoint in there. And in the next command, that's what we're doing. We're saying use kubectl label, and there's another lab which explains label in more detail. We are putting a label on the pod web, and we're saying the key for the label will be app, and the value will be Nginx Service 1. The moment we do that, and we go back to our URL and refresh it, you're going to see that you get the desired result. Yeah, you're right. Ports are a little bit confusing, but as you go deeper, there's a reason they're kept that way. The community as an all is trying to make it simple, but it'll gonna take its own time. So it is still easier to set up the lab over here. If you want to do the setup in your environment, I'll give you a quick reference. I would suggest if you could join the Google Meet after we are done with the YouTube Live, we can discuss over there and have open questions. This is more specific to the basics, so let's keep it that way. Although I'm happy to cover it on the YouTube Live as well. Okay, so we got the label and our service started working. We can do a dry run. So most of the things we do in the Kubernetes are done with the YAML file. And let's say you want to test whether your command will run or not, and you want to get a YAML file to be able to customize it. You can do the same command which we did, kubectl run web image nginx, have an option of dry run client is equal to client. That means no changes will be made. Just verify this command and dash o with YAML. This will give you the YAML file or YAML information for you to be able to utilize and modify. So API version, kind, metadata, all if you take this information, put it in YAML file, and use YAML file to deploy, you will get the same result. Now, let's say for some reason you want to figure out which node your pod is running on. The command to check that will be kubectl get pods dash -o which will tell you that your web pod is running on node 2. Actually, that's the only worker node we have in this cluster. As again, we just practice the delete command again and clean the environment. Okay, so we created a service not via, when we created via expose command, that's a way to create a service. We give the object specifically what we are trying to expose. So you don't have to have a separate mapping for it. The Kubernetes will take care of it. But when you're creating it with the service, it expects a certain label to be on that pod, and that is used as a selector. Again, deep on that could be in a another setup workshop or a lab where we explain these things. But selector is the way the service will say whether that pod is part of the service or not. And here it's the default app is equal to nginx service 1. So what we did is we went to label that pod as app as a key and value as nginx service 1, and that solved our problem of no label or connectivity. So if I go, well, now the pod is deleted. If I create the pod again, sorry, we have to do it with the port 80. If I do the describe service now, you will see it will be part of the endpoint as soon as the pod comes up. Okay, it's a little confusing, but if you really want to create your own environment, these are the steps you have to follow. I will put that in the description of our um, video. And remember that we will have a lab on those. So you will have structure steps from our side. On the Kubernetes website, they're a little confusing. So first, before you create the cluster, you have to install the tools. You need kubectl to be able to manage the objects inside the Kubernetes cluster. You need kubeadm to be able to create the cluster. So you have to install the Kubernetes, and you can install the kubeadm and you can create the cluster with that. Also, you would need a kubelet, which will gonna work with a container runtime to manage the cluster as per the desired things you have inside. So in order to install kubectl, this is the steps you can follow. And I think there is a choice between whether you're on Ubuntu or on CentOS. And it also has the steps for administrating a cluster. So if you're doing on the labs, you can on a Docker Labs, Most of the time, you don't see the challenges, but it's actually a good thing that you have to create them again and again as you get more familiar with them. And you have more questions which you seek answer for. Okay, let's switch to the question because with time, I guess we'll not be able to cover the next lab. Just to give you an idea, pod is the smallest unit. We don't go and create pods in the production environment. We generally work on the deployment, and deployment create the replica set, and replica set create the pods. Now, if you decide to do these labs on your own and get stuck, there is a video below it which you can follow along. Excuse me, which you can follow to see, and these are quick videos, so you can always catch. Pretty much all the labs have it, or we are working on those. Yes, the services, the endpoints are attached by the labels. If they don't have their ports do not align, then it won't work because the service will send the traffic and pod will not gonna accept it. Kuberium is similar to COPS, yes. It totally depends on the team, what they want. There are pros and cons of using one of them. So deployment is a group of, it's a hierarchy. So let's say you want to create 10 pods. By the steps we have understood so far, you have to do kubectl run kube 10 times, which is not a desired result. So we create replica set. In a replica set, you will say, let me quickly go to the lab and show you. If I go to next one, this is pods with YAML, and next one is the replica set. So in the replica set, we say, we give the template of the kind of pod we want, and we say, by the way, we want 3 of them. So replica set will have a hierarchy. It will have any number of pods you want underlying it. So you scale it to 3, it'll have 3 pods. If you scale it to 10, it's going to have 10 pods underneath it. Now, when you're changing versions, let's say you have image, your release 1.0 and then you go to 1.1, deployment will help you with all those things Kubernetes has promised in terms of rollout and rollback. What it does is when you initiate and you say deploy my application with 1.0, it'll gonna create a replica set and have your application with 1.0. Now, after some time, you go to deployment and say, now my application has changed, deploy 1.1. Deployment, we're going to create another replica set, give it 1.1, and slowly reduce the application. There's different ways, different deployment strategies. I would suggest watch our video on the YouTube channel where you're watching this YouTube live right now. In the Kubernetes playlist, you will get better understanding of it. But the whole idea is, if you have a deployment and you have 2 replica set behind it, you can make any one of them active. So if you move to 1.1, you can reduce all the pods from 1.0. You scale it down, and 1.1 replica set, you scale it up. Now, if you want to revert, you have to just reverse. The replica set which holds 1.1, you remove the pods from it, so you scale it down, and you scale up the one with 1.0. That's the capability of the hierarchy when it's built. And deployment and service is totally different. So deployment is the hierarchy which you have built, a pods, replica set, and deployment. Service is a grouping. So you group the pods together to offer as a single service. Service doesn't have any management control over the pods. So you cannot scale up and down the number of pods with the service. What service does is it accepts the traffic from outside the Kubernetes cluster or within, and it'll send it to the appropriate pods. Okay, if we don't have any more question, let's cover the difference between the different type of services. Cluster IP is a service when you need the grouping or the load balancing within the Kubernetes cluster. So let's say you have a web, you have app, and you have a database. Now, app is only available for the web to make the calls, and app make the call to database. So you can have a cluster IP service for the database and the app as it is required only within your Kubernetes cluster. Nobody from outside the Kubernetes cluster can access the cluster IP service. Load balancer is the service available via public cloud. So in the public cloud, when you create a load balancer VIP, Kubernetes will do it with the help of Cloud Controller Manager. It's a component inside it. So it will make the API calls to your cloud provider and create the load balancer service for you if you decide to use the load balancer type. Again, it'll cost to you, and you would have to pay for it to the cloud, public cloud. But Kubernetes will orchestrate and create that for you and add the pods. So what it'll do is it'll create a node port service and then create a load balancer service, and it'll map the load balancer service to the node port service. So next, let's come to node port service. What node port does is, let's say in this case, we have two nodes in our cluster. There's a specific range from 30,000 to 30,000 X number, which serves as a node port. When you create a service as a node port, every node, so node 1 and node 2, will expose that port outside and offer that service. So in that case, you can go to either node 1 or node 2, go on that specific port, and it'll route you to the pod and give you the service which you were expecting. So that is the difference between cluster IP, node port, and load balancer. When you create a load balancer service, because node port is 30,000 something, and that's not what you want to give it to a client. So if I tell you in order to access sharelearn.com, you have to go to sharelearn.com:30,001 or 30,100, you might not be very comfortable doing that very often. That's the reason if I have to, I'll create a load balancer service, which will take your service on port 80, and then in my Kubernetes cluster, I'm going to have a node port with different port numbers, or let's say 30,001. The load balancer will have all the nodes as the real server behind that VIP, that virtual IP which you're accessing from outside. So you will come on port 80, and load balancer will send the traffic to the real servers on the desired port of node port which we want. So that's how the load balancer service will gonna work. Um, we we shared it one of the diagram, but if you go to concepts on Kubernetes documentation and cluster architecture, control plane communication, there was a diagram. Give me a second. Overview. Kubernetes components. I can put that in the chat if you want. So here you can find the diagram of the Kubernetes architecture. So these are the control plane components which sits on the master. These are also the control plane components which sits on every node. Yeah, I would. We will be working on those labs, but not yet. Yes, you're right. So in case of a load balancer service, we'll be going to load balancer, going to node port, and going to the bot. What the benefit it offers is nobody has to remember the random port number, the 30,000 thing. And that's where the ingress comes in. So now if you have 20 websites hosted in your cluster, you don't have to create 20, or I should say the sub website. So let's look at Kubernetes IO/docs or docs.kubernetes.io. In that case, you would have to create different load balancer as they're resolving to different pods. Just let's say that's what is happening. Ingress solves that problem. Ingress will do those rules-based routing for you. again, a little advanced topics. We'll keep it for different sessions. Right now, we want to keep it basic. Want to get your hands dirty and get you some experience on Kubernetes and understand how it works, functions, what are the basics of it. I'm sorry, I muted you, but you can unmute and we can talk. Yeah. So yes, the cloud load balancer will be sitting outside. It'll be just like Elastic or whatever is offered by the public cloud. Hey, Jayant. This is not Jayant. Sorry. Hey, again, you went on mute. Sorry. So yeah, if you have any questions and you want to put it in words or talk about it, please come on to the Google Meet and we can talk. Um, Everyone can still hear us, but yeah, it'll be easier. Um, so Ingress is, hey, yeah, hey, Murgo. Hey, I can hear you. I'm sorry, I wasn't mute. Can you hear me now? Yeah, sure, we can connect there. Um, just do me a favor, go to that Let's Talk thing and book some time. Probably 15 minutes should be good enough, and we can discuss those. Yeah, yeah, welcome. Yeah. Okay. Anybody has any other questions? Well, thank you for your time, guys. Don't forget to smash the like button. It helps everyone to get familiar with this video and similar videos, and share these videos with others so others can have access to it. Share the website so they can access and practice as well. Thank you, guys. Thanks for your time. If you want to continue discussion or have something you don't want to share with everybody on the YouTube live, let's connect on the Google Meet and we can talk there.